Hello students, welcome to exam list. In this lecture we'll discuss about velocity in Cartesian and polar coordinate systems. Okay, first of all, what do we understand by coordinate system? Coordinate system just helps us to find out the position of a point. For example, if I have a particular point here, then if you are using Cartesian coordinate, say this is x and this is y, then you will say that this point is located at x comma y. You all know this basic stuff, right? Now if you want to locate this from origin, then what you do is sometimes you draw a blue line and you call this blue line as a radius vector. What do you call it? You call it as a radius vector and you represent it by r vector. Okay, now what is the location of the point P? The location of point P is x comma y. X is in which direction? In the I cap direction. So from here till here is x in which direction? In the I cap direction. So and from here to here y in which direction? In j cap direction. Okay, now how is this r can be written in terms of I and j? This r, which is the radius vector, it we know that any vector can be represented in two components. Okay, all of you know what is two component. It can have an x component in the I direction. Remember here that this is magnitude. Okay, keep it in your mind. This is what? This is magnitude. Let me write it as magnitude. Okay, and then it will have a y component, ry in jth direction. So what is r of x? So it is quite clear that r of x is nothing but our x, because x is the position of the particle along the x-axis. So xi cap plus ry is nothing but y j cap. It's a very simple thing. Okay, now you know that this is the representation of a radius vector r in Cartesian coordinate. That is, I can say that the radius vector r is written in terms of x and y. Okay, but we know that there is one more coordinate system called as the polar coordinate system. In the polar coordinate system, we use, instead of x and y, we use r and theta. More precisely, instead of using I cap and j cap as basis vectors, we use r cap and theta cap as basis vectors. So now my question is, how can I represent my r vector in terms of r cap and theta cap? Let me remind you, r vector is the radius vector for point P. Now every point in 2D, if you can look at here, we are talking in 2D. Every point in 2D needs at least two coordinates to represent its position accurately. For example, you cannot just represent the position of point B using only x. You need x and y both. So this is in Cartesian. Similarly in polar, you need at least two coordinates to represent exact position of point P. You need to say at what angle theta it makes with x-axis, and from origin what is the r. So if you have the information of the r value or the r vector of an object and the theta, then you can easily locate the point on the graph. Okay, So now my question is, in polar coordinate system, how the r cap is represented. So the r cap that represents the radius vector equals to magnitude of r into r cap. Okay, but now you will ask a question, this is weird. You said that every point needs two coordinates on a 2D system to be represented accurately. But here we are using only r. Where does the information of theta go? If you look closely, then the information of theta is actually encoded in r cap. Okay, so let me tell you how. Look at this expression. Let's write this expression in polar coordinates. Okay, so you have r. See, even if I'm writing this expression in polar system, but I'm not using polar basis states. The basis states are still I and j. So what is x? We know that x is r cos theta. Okay, you all know these things, I'm not repeating it. So x is r cos theta. So even if we have used polar coordinates, but the basis states is Cartesian, that is I cap, and r sine theta j cap. Okay, so when I'm talking about various coordinate system, I'm not talking about writing in terms of r and theta. I am actually talking about we write the same expression in different basis states. So it's all about changing the I and j and writing it in terms of r cap and theta cap. This is my idea. Okay, so you know that r can be written in this way, but remember, when you have I cap and j cap, it means you are still in Cartesian system. Although it looks like we have used r and theta, but we have not used the polar basis states. So you cannot say that we have moved to polar coordinate system by writing this expression. It would be wrong. Okay, but so this is still in Cartesian system because the basis states have not changed. Okay, what else can we do? What is r vector? R vector is made up of magnitude r and r cap. So if I write only r, okay, so if I write only r in the expression, then know that it represents the magnitude of r vector. Okay, so I want to avoid writing this modulus again and again, so I write like this. So this is equal to this expression. Okay, so this is equals to this particular expression. Everything is okay. So what I want to do, is I want to cancel the r in the left hand side and the right hand side. So what happens? We get r cap equals cos theta I cap plus sin theta j cap. Okay, understood? So what do you understand from here? You understand that anyhow the r cap is going to be a function of theta. That means in polar basis states, what are the polar basis states? R cap and theta cap. So when I write the r vector in polar basis state, I'm actually writing it as magnitude of r. Okay, and I told you that instead of writing this, what I will do, I'll just write only r for my simplicity. So r, and I should write r cap, but remember that r cap is a function of theta. Okay, I hope this thing is quite clear. Now another question is, can we go from here. Is there a way we can convert this expression to this expression? Let's try to do it. Okay, so this is r. Now we want to go from polar to Cartesian. So when we want to go from polar to Cartesian, we can replace r cap, and we see how r cap looks in Cartesian. This is how r cap looks in the Cartesian basis states. Okay, so let's put it down. So instead of r cap, write cos theta I plus sine theta j. So you get r cos theta I plus r sine theta j. Okay, multiply r inside. What is r cos theta? R cos theta is nothing but x I cap, and what is r sine theta? It is nothing but y j cap. Okay, so you see everything is related to each other. So now I want to summarize. Okay, so let me clear the screen and let me summarize. That would be better. Okay, what I want to say. If you have a point in Cartesian coordinate, then you need two basis states, I cap and j cap, and you need two coordinates with respect to two basis state, x and y, to represent a point in Cartesian system. To represent a point in polar system, you need two basis state, r cap, theta cap, and you need two coordinates. You need to know r vector, or it's better I say you need to know r, and you need to know the value of theta. Okay, next is to represent the r in Cartesian. What I want to do is I want to represent the r vector in Cartesian. Then to represent the r vector in Cartesian, I'm going to use the x, which is the coordinate, and the basis state I, and I'm going to use y, which is the coordinate and the basis state j. But to represent the r in polar system, interestingly, I only use r magnitude and r cap. But as I said, that the information of theta is also here. Where it is hidden? It is hidden in the r cap, because we saw that r cap is a function of theta. Okay, so here what information we have? Here we have information of x and y and the basis state, and here what information we have? We have information of r and theta. The information of r is here as magnitude, and the information of theta is hidden in r cap, and we have used r cap and theta cap. As I said, theta cap is very in a hidden way. Okay, so this is all the idea about representation of radius vector in Cartesian and polar coordinate. In the next lecture, we'll look at velocity in great detail.